Okay, recording on. So welcome to week 11. We're going to first start by reviewing module 10, and I'm only going to review the quiz and only question 7 because it was the most highly missed. And basically the prompt was, please add yourself as a new employee, hence the employee table. I know it wasn't explicitly stated, but that's the whole idea. And we talked about the columns that were not null. Most of you got that, but a few people selected all of them. And really the only ones that are not to be selected or not required is first name. And what was the other one? There's 2 of them. What's the second one? You know, first name is one.
Phone number.
Phone number. There you go. So those 2 were not to be selected to get the full 2 points. Ooh, I know that's a lot of points, but good job on the assignment. Everyone's getting the hang of this, or at least the hang of what I'm asking you to do. So I do appreciate your hard work. Continue hard work. So just keep it up. No fair slacking off now. It's too late to do that. Keep moving forward. All right, on to module 11. And as I said, there's a lot involved with this module. Just turn myself on since I do most of the talking. So we're going to talk about the DDL part of SQL, and that's the data definition language, and basically the whole idea around the entity or table, creating it, modifying it, etc. And then along with that, we're going to talk about constraints and how they guide and protect the data, etc. All right, so our objectives, list and categorize the main database objects, which is important to understand the DDL and how it's instituted in SQL. Reviewing the table structure, we had a little bit of that. We're going to go a little bit further, talk about other attributes of the table, describe how schema objects are used by the Oracle database, so basically the system, create table using the appropriate data type for each column, very important. I'm going to briefly go into, I'm going to, expeditiously or expediently run through external tables. There's a reason why I'm doing that. It's not such a big process anymore. Yes, in my day, it was very important to understand the use of flat files and external tables. Not so much anymore. So there's other processes that are a part of the Oracle Academy. This is probably the one thing that's more fascinating than anything else. And then the data dictionary, though, although is very important. So you're going to query the data dictionary to obtain many of the attributes of your database objects. All right. So up until now, you've selected, updated. So you use the DML, and basically you've looked at projections, you've changed data. As a DBA or possible DBA, basically you're expected to know how to create tables, actually create the relational model. And we're going to talk about that now. Our tables are small compared to regular companies, but the one reason why Oracle is sticking with the schema that we're working with is it is truly a kind of a microcosm, or it's very indicative to the tables or the table structure, the relational database schema that you'll see in the real world. Employees and all the cursory tables that go with that. So it is what you're learning now, it's a pretty good symbol of what you'll see in the workforce. And once again, Oracle mentions flat files. I will tell you now, I haven't used a flat file to create data for about 40 years. So I'm pretty sure that they're obsolete, but Oracle, as with most of the things, they refuse to kind of sunset some of these items. The data dictionary truly is important because you can pull in lots of information based on your knowledge of queries. So, right. And this is very important. And yes, you'll see this on a test sooner or later. The main database objects are table, your index, your constraint, the view. We talked about views, sequence, and then synonyms. Now, sequence and synonyms are they're losing their level of importance, but you need to know what they are. And some of these objects exist independently. Primarily what you'll be concerned about, I will tell you the top four table index constrained views are still commonly used. So Oracle says that it's important that you know that some of these objects do take up space. They do take up storage. They do take up memory. Not a lot, but if you have millions, if you have, a large database, petabytes, yes, depending upon your objects, they may take up a substantial amount of storage space. It used to be something that we were really worried about. Not so much now because of the way things are organized, and now we have what's called cloud, which offers another layer of resources. So anyway, views, constraints, sequence, and synonyms are also objects, but basically they don't, essentially the whole idea is that they don't require a lot of space or storage in your database schema. This is important because if you happen to become a database administrator, the first thing you need to find out is how much storage you have, whether it's cloud or on-prem. All right. This slide talks about database objects, how they're organized, and how you can access them via the data dictionary, which is truly a good environment where you can basically understand all the attributes of your tables. And it talks about select statement, and we'll get into that. I mean, you don't really need to worry about it, but know that just about everything that you do to manipulate or to create your objects, you can capture that essence by querying the data dictionary. And here's kind of an example of looking at schema objects. So basically, you should know the name of the tables, and you see here, what I'm going to allude to now is very important. It's the Object Explorer. If you open up the your SQL developer, you can gain a lot of information. Now we've had the describe statement, but if you open up the developer and click on any of the tables, you'll get a list of the attributes of your table: the column names, the data type, a nullable, date default or data default, column ID, and comments. And then you have these several tabs, and basically they're self-explanatory, and you don't really need to know all of them at this point. And essentially, even if you go into if you're really curious, you can go into any of these tables and any of these tabs and figure out everything you need to know without me rambling on about the table. So if you want to see details about this table specifically, we're looking at the jobs table. So if you take a look at the SQL developer and expand the ORCL schema, that's your schema name, believe it or not, and then expand the tables. And for example, if you click on the jobs table, then you'll see just a double click, and just to prove this is true, it'll expand to the column names and you get the requisite information. And you should do this just to see, you could actually see the data that's in that table. Essentially, I don't know if the model works. There's specific things that you can get from the tabs, but I'm not going to go through all of them because they may take time. But for now, take a look at this view, because this is a very basic view of the structure of your table. And the object browser is what it's called. That's where all your basically your schema and how you can expand things. And as a matter of fact, I mean, if you're really interested to try and outline some of the attributes of your table, you don't really have to run a query. And then as you see here, there is a SQL tab. And if you basically open that tab, and I'll show you, this basically shows you how this table was created. Of course, there's a lot more here than what we will learn today, but I just wanted to show you that if you're really curious about going into any of these tabs, very useful information. So, and then to compare that with the describe, remember the describe DESC statement, this is where you want to start, because that will ensure that you know which column is nullable and which is not, and what the data type is. And that's probably as important when you're looking, or even after you've created the table, to understand the structure of the table. All right. All right. Table creation, just now that you kind of know the outlying factors, basically, when you create a new table, you use the following rules, and yes, you'll see these later. The table name must begin with a letter. It must be 1 to 30 characters. That's still a rule, and primarily, you want to stick with that. It must contain only uppercase, lowercase, the numbers 0, our number objects, an underscore, a $, or a hashtag or pound sign. Those are the only characters that are allowed in your table name. But remember, it must start with a letter. And then after that, you can do whatever you like. Generally, when I created tables, it was always, and it followed my programming days, it was always a lowercase letter, and then an underscore, or something that define that particular table, like customers or products. But for me, I mean, it's back to my programming days, but everything was lowercase. So you go back to the old Unix and IBM days. But anyway, I digress. So you must not duplicate any of the names. Your table names have to be unique, and your object names have to be unique. And we're going to get into that fun stuff here. And there isn't a list of reserved words like table. You can't name your table, and that kind of makes sense. But all right, so thinking of naming conventions, and I mentioned this briefly, in Oracle, it is, well, in any schema, it's best to use descriptive names like students or employees. And then essentially the case is important, so, or it's not important, I should say, but the way it's read on the system, you do want to be consistent. So uppercase, lowercase, and as I said, back in my DBA days, everything was lowercase. For me, that made more sense. Table names should be plural. That's kind of a standard. So employees, for example, or students or faculty, that's a plural. That's or teachers, if you want to go that route. Other DDL statements used to set up, change, or remove data structures from tables include alter, drop, rename, and truncate, and we'll get into those. All right. As I'm accelerating through this, you're probably wondering, what's the syntax? Well, you got it. Create table is how it starts. Create table, and then your table name, and then each of your column and your data type. And if there's a default, we'll talk about that later, the default. I mentioned it before, but we'll illustrate, or I will illustrate what that actually means. That can be omitted. And here's some examples. And yes, you are allowed to create tables in your schema in the ORCL. So when I go through these examples later, you can follow along by actually creating the tables, especially the whole date and time. But here, create table, my CD collection, and CD number is the column, that's the table name, the column name is CD number, and it's a number, titles of varchar, artist, varchar, remember char is variable. We'll talk about data types in a bit. And then your purchase date, and we're using a data type, and using a default and sysdate, which means that whenever this, well, I don't want to jump ahead. But if you do a describe on this table, you see that. And we did not set any constraints, and we'll get into that later. But now we have this. This is how this table is described as. We don't know what the null is, but that's our data types. All right. And then here's another one, create table, my friends. Just another basic example, and this is the description. Does that make sense to everyone? So far, so good. You're all ready to create your own database, which is coming soon. So don't fall asleep. All right. Well, later anyway. All right. So as I said, I'm going to go very fast through the external tables. You can review them if you like, review the slides. It's something that's good to know. I'll just summarize that way. You probably will not. I could be wrong. Don't quote me on this, but you probably will not run into someone that's going to be importing or exporting data to a flat file. This was huge back in the 80s and the 90s, not so much anymore. But Oracle thinks it's very important that you know this. And generally, when there's any type of merge, especially when there's legacy systems involved, you'll see it. A flat file is essentially exactly what you think. Think of a piece of paper that's filled with text. That's a good analogy of what a flat file is. It's usually just rows and rows of just text, and you have a delimiter and all that. And you can enter in the delimiter and the column names, headers. If you ever create a CSV file, you can look at it using Notepad or any of it. That's kind of like a flat file. Does everyone know what I mean there? Hopefully. And that's essentially what you would see in a flat file scenario. So there are benefits. In fact, Oracle, basically, you just need to enter in that it's a flat file or a file type, an extension, even a text file. And basically, the Oracle system will figure out. So if you needed to add, and you can review this, I haven't run anything like this for many, many years. But basically, I'm setting up a way that I can create a table based on this flat file called info.dat. And I'll let you read through that. And it's all that you see here. You're defining the delimiter, defining basically the column and the data and matching it up. And that's what this is. So this is a description of what you see. I am kind of glossing over it. You do have a pretty good example in the practice and solutions, but yeah, you can go ahead and read through this as you understand what, and that's basically what we refer to as external tables. All right, enough of that. See, that wasn't too bad. So let's move right into the data dictionary. Data dictionary is still rudimentary and fun. Okay, it's not that fun, but it's important because you can basically understand all the objects in your table, or excuse me, all the objects in your database or in your schema. User tables created by you containing your data. Well, you don't really have to worry about the user table because you have really no control over that, but you should understand that you're a user in your schema and just remember that. But primarily, all the objects that are in your schema are controlled or contained in a data dictionary. And we're going to run through a few. These tables you don't control, they're system tables. You can't modify any of the data. They're limited and have constraints around that, but you can access any of the information. If any Oracle user attempts to, so basically this is saying if you have multiple users, if you're in a real environment, you do have users, and you need to understand that you have your database administrator have basically provided an access to you for your specific type of data. And there's many ways around that as far as whatever the structure was, but you can access that information, and that ultimately I'm just saying that you can access that information with the data dictionary. All right, so for example, here's a couple that'll blow your mind or not. There's a lot of data, but here, select table name status from user tables. And basically, you're getting a list of all the tables in your schema, which you have access to. So, and these should all look familiar, somewhat familiar, and should match the same list of tables that's in your Object Explorer or which is this thing right here. So, and then you see that dual table. This is This is user tables. This is all tables, and that includes all the system tables. So you see the difference there, and it's a long list. As you see, this has 50 rows. This has well, at least 50. Yeah, that's 50 rows. This is 42. So it's a lot of tables in this very, very abbreviated schema that we're dealing with. But these are usually pretty normal, especially the system tables. You see that in most Oracle type databases. Maybe you'll see a little bit more, but yeah. So if you want to do something interesting like investigating indexes, and we all know what an index is, then you can actually access the user index. And it's, oh, what I did want to tell you, most of the tables in the data dictionary that you have access to will start with the indicator user and then underscore. And it's usually, as you see here, it's indexes or sequences, but that'll give you, as you see here, select star from user indexes, and you can see all the indexes and basically the primary key and all the other foreign key, all the other types of indexes. And usually it's indexes are used, and we talked about that, you to either create the primary key or yeah, I won't go into the details, but we will talk about that when we go into indexes. All right, so there's a lot of information there. This is just all of the columns in that, and it is a real table in your schema. All right, here's another one. Select star from user objects, and this is a higher level. You're just looking at objects where the object type is a sequence. So you can either use the objects or the indexes. These are all, see here is the indexes, there's a user sequences table, but they're all, of course, there's all kinds of redundancies. So we try to confuse the heck out of these. So that's the start of the data dictionary. You can even look at all the tables. You can even look at all the types of tables using the data dictionary. But that's a quick intro along with the create table and then external table. Remember, the schema is essentially your database, and then default value in your column. We will talk about that more as it comes. So I'm checking attendance. Okay. All right. That wasn't too bad. That was section 1. Let's move right on to section 2. And this is data types. So we're going to primarily focus on the date time. That data type is usually the most confusing. Oracle thinks that if we can focus on that, then the other varchar and char and those two in numbers are pretty straightforward. So we're going to look at the timestamp and the timestamp with time zone, data types, interval year to month, interval. These are just useful ways, and so you'll think, well, I probably won't use that because I can probably do it many other ways. In most databases, you're not using these types of functions. But this primarily in this section, we're going to talk about data types, but we're going to, as far as examples, and I would recommend that you either follow through and work on these yourself. And then we're going to look at the actual data types, the number, date, and character. Those three are primarily the ones that we focus on. All right, so we're going to start this out by asking you, have you ever traveled to a country? And we all know that currency is different and time is different and blah, blah, blah. We all know that. We don't have to think about it. We're expecting that. So we're going to look at that a little bit towards the end of this section. But first, you're probably asking, okay, what are these data types that we need to concern ourselves with? So different data types offer several advantages. Columns, basically your column has to be of the same data type. Date data type, always produce date values, etc. And basically you can't insert a wrong type of data into the column that doesn't match the data type. Hence, that's why you create the data type in the first place. And you cannot mix data types within a column. Basically one column, one data type. All right, so the most commonly data types for a character and number are, for characters, char, which is a fixed data type of a certain size, basically maximum 2,000 characters, and it's pretty common, and you'll see that A varchar is variable size, and that's a difference. So fixed size, variable size, maximum of 4,000 characters. Larger varchar is probably the most used in regular relational databases. The CLOB, and that's just basically stands for large object, and usually that's used on a different type of database, but know that you'll see the term CLOB out there sometime. But the maximum is 128 terabytes, so that could be a pretty large object, and that's what CLOB and blob. You'll see blob later. And then number is just number. Basically, the max precision is 38 digits. Back in the, well, yeah, there's one point where they decided 38 digits was enough to encompass any of the numbers used, but back in the old scientific days, sometimes they would say that probably isn't large enough, but for Oracle, 38 digits. Remember 38. All right, for date and time, you do have date, you have timestamp, and you have interval, which is a type of, measurement ordinal. You do need to know, but those are essentially all date time data types. And we do have what we call binary values, and this is usually, and it's definitely used for different types of images, audio, and video. We don't have MP4 on now, but you do have video files in this type of binary values data type, and it's become pretty common. Yes, streaming services like Netflix, they actually store entire movies, which are video files, which are pretty large. So you have two different types of raw variable size with a max 2,000 bytes, which is obviously not that large. And then you have the blob, which is your binary large object, and that's up to 128 terabytes. As a matter of fact, I think some of the binary objects now extend beyond that, and they are accepted. So I just remember that blob, and that's different. I liked it in CLOB, as you probably figured out, is character large object, and blob is binary. So there you go. You can answer those. Use those answers for a trivia question. So those are your common data types, the most that we'll see in our little adventure. All right, let's extract, or let's detail some of this. So for character values, it's usually better to use varchar or CLOB. You won't have to use CLOB because we won't have anything that large. Let's use varchar. Char, remember, is fixed size, and it does save space if you use varchar. Just remember that. So when you indicate your data type varchar, and then you give it a size, and just give you a definition, varchar dirty column, only the 5 significant characters are stored if you have the last name chain. And then the 25 trailing spaces will be stored as well to make fixed size of, well, basically, you do want to indicate enough for a very long name. And remember, these databases are these data type, and I'll just tell you this because you won't, this is not a part of the lesson, but you're not actually impacting resources when you set a varchar at this size, because the system will actually recognize the difference between chain and a very long name and allocate memory and et cetera accordingly. So, and that's just saying, basically, you don't want to use a fixed size because the variable, there's adjustment to char, there isn't, and although it's not a big deal, but we do need to consider that. And then numbers can be negative as well as positive. For example, if we use this indication 6,2, that can store from the plus 99.22 because we have 6, so 6 total digits, excuse me. And remember, we can go up to 38. So, but the decimal, you're indicating the decimal point. That's the decimal places on the right side of your little dot there. So does that make sense to everyone? I'm pretty sure it does. All right. All right. Daytime data types. These are usually the most confusing one because they've changed quite a bit over the years. When this lesson was created, for example, there was a big concern about Y2K and all that, but now the default data type is back to DD MON, which is a 3-letter month, and then just 2-digit year, and then whatever your time is indicated. So we're going to go through a few examples, and you'll see what it looks like. Primarily, be very careful when you're using the date timestamp. So here's some examples. You can run through them with me, but you don't necessarily. So here's our time example 1 table. We're just creating a table with one column. We call it exact time and timestamp. And I ran this yesterday, and I'm inserting the data, and that's the manual entry. And you notice I get day, month, year, and then just some arbitrary time, 1052. That was in Oracle, and then dot whatever second allocation. And then if I wanted to insert in here the sys date, and then you'll see the difference between sys date and sys timestamp. These are system, basically system allocations as far as dates. So when you look at this, you see that we have that manual time, and then the time that I entered yesterday, 1 o'clock p.m. And then you notice the sys date basically goes down to the second, where the sys timestamp goes down to the microsecond. So just remember that if you need that level of precision. So that's the only difference there. All right, makes sense? Thumbs up. I know this is very exciting information, right? So you need to consider, to some degree, not so much anymore, but the differences in the time zones, and so you can actually do that or perform those type of data configurations within your table if necessary. Although, once again, back in the old days, we were always trying to figure out what's the universal time, what's the GMT, how many hours plus, negative, what time zone. It became a headache. To be frank, most database systems will do that for you. It'll automatically know your location, and will add whatever the time is based on the Greenwich Mean Time, which is, we all know that's the UK, etc. So you really don't need to be cognizant of your actual time zone. So kind of illustrate, if you were very concerned about that, our second example, we're creating our time example 2. We're going to have a time with offset, which means we're offsetting from GMT, Greenwich Mean Time. We're at -7 here. Yes. So, and you'll see what this looks like. So that's our actual data timestamp with time zone. And then we're going to insert our sys timestamp, and then we're going to insert a manual with basically a manual offset +2, which is Eastern. Is it +2 or -2? It's +2, right? And if you do a select with that, you see that we are -7 on the from the GMC, and basically we can offset, so the Eastern time zone is +2 from where we're at now. And the thing of it is, you notice here I'm just putting in a manual time. If you want to know the difference, basically you want to do sys timestamp. That'll give you the difference, and you can adjust accordingly. All right, so timestamp with local. This is another one of those functions within Oracle. Let's say you want, in our next example, we're going to have 2 columns: timestamp with time zone, and then timestamp with local time zone, so that you see the difference. And then we're just going to insert some manual values, and see that both values are stored with a time placement of -7, because we're a part of the Pacific Standard Time now. And so this is what this looks like. Oops. And so this whole idea, what if someone in Istanbul executes the same select query on that same table? They would see here it's November at 8. They would see that it's basically, it's the same date, but it's 9 hours later. And that's embedded in the system, which is why there's not a big concern about understanding if someone was to run that and you had that table set up to indicate the local time zone, they would not have to worry about, trying to adjust. So you would know when within the table, if that was necessary. Usually that's not necessary. It's something that you can be aware of. All right. So these interval data types, they can be used. I rarely use them, even back in the old days, but it's a way to store elapsed time or some type of interval. And I'll show you a couple of examples. So there's an interval year to month, shows a period of time measured in years and months. And then data second stores a period of time measured in days, hours, minutes, and seconds. If you need to set up that type of interval. And so the syntax is interval, year, then whatever year precision to month that you have. Year precision is a maximum number of digits in the year element. The default value of year precision is 2. So you see here in our example, this example 4, we're going to call this long durations, 2 columns, long duration 1, long duration 2, interval year as far as the year 3 to month, so 3 years, interval year 2 to month. You're probably thinking, well, that's just going to set an interval. We have to set the values. So if we insert data into that, the values would be 120, and you would think that if that's year of the month, then 120 months is how many years? That's 10 years, right? But we're going to call it a long duration of 120. And then 3 to 6 is basically 3 to 6 years. So yes, we can set those values. So when you do a select on that, you see 120 months from now or 10 years from now is 36, 3 years and 6 months from now. So there you go. That's an interval. So 3 years, 6 months from now is October 29. So it's just a way to allocate an interval if you need to do that. There's other ways to do that, but this is an interesting way to do that within the Oracle database. And there's another level of precision. Yes, you got it. Day to second. Basically, it's the same idea, but you're going down to a lower level. So I think this is our last example. Basically, we're going to 2 columns that are basically the same, that will accept the same type of value, and then we indicate whatever data we have. So 25 days to now, and then 25, basically how many, 4 days, and the seconds from 10:30 at 10. Yes, it seems very convoluted, but so you see here 25, oh, that should say days, not phase. That's something different, right? Typo. And then our second 2-char sysdate plus duration, basically precise days and time from now. So it's just 4 days. 4 days and so many hours, minutes, and seconds from now. And that's where 4 days, 10 hours, 30 minutes, and 10 seconds from now, from the point that I ran that query. So yes, are these useful? Possibly. It's just a way to set an interval if you need to do something like that. Normally, I will tell you this now, normally this is done on some front-end application or something that you're running into the data, and you're not even concerned about what the database is going to return as far as an interval. It's just another way to understand that data type, interval, if needed. And then time zone, these are useful. Are they used a lot in our current landscape? Not so much. But I did remind you of CLOB and GLOB. You need to know what those are. It's essentially large data types for char and binary, which are usually images and something multimedia, whatever. Whew. All right, we're moving right along. So now that we've learned how to create a table, obviously we need to know how to modify a table. So we're going to get into our DDL a little bit, talk about alter, drop, rename, truncate, these particular functions. We're going to look at queries to do these in several different ways, which is important. We're going to look at the flashback query, which is basically your savior to help you undestruct or undo what you may have done unintentionally. And then what the flashback table options are, and track the changes. Basically, you can actually track any of the changes that you've made either on a DML or DDL. And yes, you guessed it, possibly in the user dictionary, but we'll see. So we're going to look at truncate and delete the differences. You can actually add comments, as you saw in that little object explorer. There are comments if you wanted to add a comment, and that became very useful to me at one point. If you want to change the name or modify table or columns, and there's a set unused statement, which we're going to see how advantageous that is. And nothing permanent but change, yeah, the cliched statement. So yes, it would be nice if everything remains the same. So yes, we do have to be concerned about making changes, making modifications, even in today's landscape. So in DDL, yes. So the first thing I'm going to introduce you to is the alter table. And with the alter table, yes, you can change the table. And yes, that's the syntax alter table. We'll get to that. So you can add new columns. You can modify an existing column. You can define a default value for a column, or you can drop a column. So essentially, you can modify all of the attributes of that table. So a newly added column always becomes the last column. Just remember that. And that rule is still persistent today. You would think if you need to position it, let's say you wanted to add middle name. Well, you would have to either recreate the table, because if you add that column, if you have first and last name, it's going to be at the end, which will be awkward. All right. So to add a new column, it's simply alter table, my CD collection, and yes, the keyword add, and then your column name, and the data type, and if there's a default. So I'm adding release date, and the default is sys date, and you get the indicator, my table is altered, and you can do a describe and see that. Hi. Hi. All right. So you can see that we added our release date. And here's another one. We're going to alter our My Friends table, add favorite game as a varchar. And yes, there's our favorite game. It'll be the last column. Very, very useful. You'll probably see that a lot. All right. So some rules and restrictions for modifying column. The specific column, you can increase the width or precision of a numeric column. You can increase the width of a character column. You can decrease the width of a number column if the column contains only null values, or if the table has no rows. So that's very, very tricky. You have to be very careful about that. For varchar types, you can decrease the width down to the largest value in the column. And yes, when you try to decrease it below that, you get a nice little error. So don't do that. You can change the data type only if the column has no data. So yeah, that kind of makes sense. You can convert a char volume column, to a varchar, or convert a varchar column to a char only if the column contains null, or if you do not change the size to something smaller. So generally, that's why you start with varchar. Don't fool around with char. There's really no need to. A change to the default value of a column affects only the later insertions. That's a key here. So if you add a default, if there's data already in that column, then it won't change until something else is inserted in the table. All right. So there's some examples that I'll bust through. This table has been created, mod imp, last name and salary. Each of these modifications, which of these modifications would be allowed and which would not. So look at the 4 modifications based on the rules that I just stated. Which one, and we'll just call them 1, 2, 3, and 4. Which one would be allowed and which one would not? This is the time to interact. So what do you all say? I know everyone's mostly asleep already. How about 1? 1. All right. Since you're all very quiet,
Definitely have one.
we'll just walk through them. So One would be permanent only if columns were empty or the last names were 10 or less characters. So you see, yeah, right? If you look back, it started with varchar 20, and I wanted to show you that, and the number 82. So one, only if it's 10 or less, or 20 or less. 10 or less because that's 10 more. So so the second one, alter table, modemp, last name varchar 10, that's, yeah. Actually, this one, once again, basically, if it's less than the columns, you'll get an error. Modify salary number, we want to go up to 10.2, will be permitted with or without data, because we're going up. You're increasing, not a big deal. Modify salary number 82, and we're at default. And remember, yes, it's permitted, and the default will only be applied to any insertions to that table. So they're all, there's conditions, but they all will run. So that's the key here. All right. All right, so maybe I should play Reveille now. Make sure everyone's awake. I have my trumpet right over there. Anyway, dropping columns. So be very careful. And we're going to talk about constraints and all that a little bit, but column data containing data may be dropped. Only one column can be dropped at a time. You can drop all the columns in a table. At least one column must remain in the table before, you drop the table. We'll get into that. Once a column is dropped, the data values in it cannot be recovered. Remember that. You can drop the column with data, but there it goes. That's the one condition where you better be very careful. You can do a rollback, but yeah, be very careful when you drop a column. And the syntax is alter table, table name, drop column, column name. So in our little my CD collections, I'm going to drop the column release date, and it's gone. And then we're going to drop the column favorite game, and that's gone. We just made those. Oh well. So you can use the set unused function. So dropping a column from a large table can take a long time. So a quicker alternative is just to set it unusable so you can add data to it. And you don't need to do that for a small schema, but basically if you have millions of rows, you just want to use alter table, table name, set unused, and then the column name. And basically essentially create ghosts under that column. And it becomes invisible. And it just takes a microsecond. So yep, that's all you need to do. So here's a couple of examples. The difference between set unused and drop. So if you want to reclaim disk space, which is not a big deal, you can actually run something like this. If you want to set it unused and it just sits there unusable, but if you want to drop it, you can use the statement drop unused columns and it will drop. Now they're gone. All right, that's a secondary way of dropping your columns. All right, you can review this when I post slides, but here's a summary of your syntax and the alter table and basically all the things you can do with your alter table. Well, most of the important things, all right? Columns, modify, default, all set unused, drop unused, all that we just covered. All right, so the drop table statement removes the definition of well, basically, now we move up to the table level. If you want to drop the table, it does remove it from the Oracle definition of the data dictionary. When a drop table statement is issued, all data is deleted from the table's description is removed, and the Oracle, it doesn't give you a chance to, are you sure? I mean, it just drops the table immediately. So you can restore, and you're all thinking about that because drop is not completely kicking it out of the schema. So if you do drop a table, yes, there's a way To restore it, that's the flashback table command. And yes, or you can do the rollback too, but the flashback table will just bring all the attributes back of the table. And the syntax is just flashback table and then table name. And then you do need to indicate to before drop. And it will return everything back to where it was. Whoopie. And you're happy. You can go on with your day. So this is our example. Basically, it's like throwing it in your trash bin or recycle bin, and then you can actually go to your recycle bin and actually restore any of your. Well, you all know that even after you delete from your recycle bin, your data is, if you're thinking about Word, is still not gone. How many of you knew that? You can actually restore that. If you know anything about the Windows registry.
I didn't know that.
Yep, you can. So if you want me to teach you that lesson, then I can do that. But it involves a little bit of work, but yes. All right. The user recycle bin, this is actually part of the data dictionary. So you can go in there and actually see what tables have been dropped, which is why when you drop them, they don't really completely go away yet. And I'm just giving you some idea. So you can pull out information like when it was dropped, the time it was dropped. If you're doing some type of auditing, etc., yeah, and that's happened to me before. So, if you want to bypass the recycle bin, basically you can use the keyword purge. Once again, this is like deleting or purging everything from your recycle bin as well. Sometimes you will run across auditing where you must do that. But even that doesn't completely delete, but at least you will not have it in your recycle bin. All right, so that's essentially how to handle dropping a table. Once again, there's all kinds of ways of recovering. Flashback is usually the quickest way, but you can do a rollback, etc. All right, renaming a table. Yes, it's pretty simple. This is a newer, this was not in existence when I was a DBA. We had to do other things, but you can use a rename command and just rename old name to new name. So if you wanted to rename your My CD collection to My Music, there you go. And then you get table rename. And of course, you want to describe the new name. If you describe the old name, it just gives you a no object exists. That's obvious. Truncate. So truncating a table removes all the rows from the table and releases it. Basically, it releases the space. So it eliminates all the records. So when you use truncate, you cannot roll back, row removal. Be very careful there. You must be the owner, and we all know that we're the owner. But truncate will just, I mean, it's pretty powerful. So if you use a delete statement, it doesn't release storage space. That's the key here. Or truncate eliminates everything, and it does not generate rollback information. That's the key. So be very sure. And once again, you don't have any type of secondary acceptance. If you run truncate, that's it. Records are gone. People are upset because now you have to, either restore, go outside the data schema. Wait, don't truncate. That eliminates all the records. Okay, moving ahead, you can add comments to your table if need be. Once again, if you look at the Object Explorer, one of those tabs says comments. If you remember that, so if you look at here, there's comments on this little tab, and you double click on the table. So if you need to comment about the table, the row, the column, you can do that. So that's the purpose of it. So comment on table, column, table.column, and then you place your comment here. And what does that look like? So comment on table employees is Western region only. There, now we have a comment on our table. And you get a comment created. So to view the comments, you go into the data dictionary. At the table level, I should say what I showed you there before was comments at the column level, and there's a difference. So you see here at the table level, select table name comments, from user tab comments, and yes, you get all the comments. These are all tables. These are all comments. We just added that one. If you want to drop comments, basically use the empty string, do the same thing, and it will go away, go back to null. And sometimes, yeah, we know that the empty string is not necessarily null, but it will basically remove the comments. All right, going back to flashback query, back to flashback. Is that a correct sentence? All right, so you may discover that data in the table has somehow been inappropriately changed. Luckily, we have a way to kind of recover. And this is the use of flashback. We talked about this before. And remember your overarching commit and rollback. You can use the flashback query facility to examine what the role looked. So basically, this is kind of a tracker. What's been happening with this table. So it actually has, you can go back and flash back to a certain part of the table, a certain time frame of the table. And so if you follow this example, basically select employee ID, first name, last name as version operation. So we're adding aliases from the employees table in this flashback scenario. And you see here, we haven't created any scenarios here, operation start date, end date. So we're creating what happened, when it happened on these particular columns, right? Here. So if anything happened, the first name, last name, then we're actually building a way to compliantly track anything that's happened for the table, for the columns in the table. So the best way to demonstrate this, and usually this is occurring. So we're gonna use the contents followed by an employee ID. So we're basically going to look at keying, what happened to keying. So, all right, so we're going to insert into our employees table this new employee. I think that I wanted that to be Natasha Hansen, Natasha. Okay, we'll stick with that. And you notice that once I've added this new employee, since this is the first change of our little query here, now we have, although we know that King is employee, oh, he is 101. All right. So now we have Natasha Hansen, and they were added at this date with that salary according to this query, right? So we have a record of that change. And if we go in there and do an update, so Natasha got a raise from 12,000 to 30,000. That's quite a bit. Actually, no, this is King got a raise. We lost Natasha. Anyway, but King got a raise from 24,000 to 30,000 a month. So now you see here, we access his record, and then we updated him to this new salary. So now we have that record in our little, and this SCN is a sequence number that you can use if you're kind of audited or whatever. So, and you see there's the categories here, there's an update and that date that it was updated, the date that it was updated. I'll try and say that. And that's what I'm illustrating here. I just explained that. So is that used, the flashback query or the time tracker query, whatever you want to call it? There's so many different ways to track activities on your table. Generally, if you're a DBA, you're keeping a record of all that's going there on there anyway, even either using the data dictionary or other ways. All right. So we're not done yet. So I know you're like, oh, thank goodness. But let's take like a 2 to 3 minute break. 3 minute break. Just to stretch your legs. We got another few slides. We're going to go into constraints and all that fun stuff. Just a couple minutes to take a breather. And so I can take a breather. And then we'll come back with part 2 of this week. All right.
Cool.
Cool. Because we have 3 more sections to do. Yeah, you're like, no, you got to be kidding. It won't be that bad. Just take a breath And we'll start up at 7:05 and go through the remainder. And it won't be that bad, so you'll be okay. You'll be able to survive. Stand up and stretch your legs, or whatever you need to do. 2 more minutes. No one seems to be moving. I'm going to stand up. I've been sitting down all day. All right. I drank all my water, so I should go get another bottle of water. All right. 1 more minute. I should start some music or something, or put a timer on. All right. Okay. We got 50 seconds. Don't watch the clock count down. That's like watching boiling water. All right. 5, 4, 3, 2. Okay, welcome back to part 2 of our learning adventure. So we're going on to section 4. It's an intro to constraints, not null and unique constraints. This one you do need to understand. These are still pretty appropriate and applicable to our current data structure and a relational database spectrum. So we're going to define the term constraint and as it relates to data integrity, which is the key here. State when it's possible to define as constraint at the column level and possible at the table level. State-wise essential to give meaningful names to constraints, very important. State which data integrity rules are enforced by not null and unique constraints. Write a create table statement with not null and unique constraints, and then explain how constraints are created at the time of table creation. All right, if you think about it, and yeah, all of these purposes are, I'll have to go in and change these. So yes, we stop at red lights. How many of you run red lights? Admit it, or speed up when it turns yellow, right? Stop doing that. We're waiting for an accident to happen. Anyway, we all have rules. Basically, in the database, we have things called constraints. It's actually the most important part of it, preventing, incorrect data values to be promulgated within your schema, et cetera, within your movement of data, et cetera. So things like, would it make sense to have negative salary, values of 6 students with the same student ID? Yeah, all of these things are common sense. So what exactly is a constraint? So think of a constraint as the database rules. All constraint definitions are stored in the data dictionary. You figure that out. And constraints prevent the deletions of tables if there are dependencies, which is huge. You probably wonder why you got those error messages when you try to delete department, because there's dependencies, and which means there's relationships, which means don't want you to be deleting things if it's depending upon others. So, and it enforces rules as far as data insertion, update. We saw that before. Now we're going to essentially extract that and define it. So there's 5 types of general constraints: the not null, the unique, the primary key, foreign key, and then the check constraint. Check constraint is very useful. We don't get into it a lot, but I've used it a lot. So as far as naming conventions, constraints are important and naming them is important as well. Although you could name it constraint and constraint one but that doesn't mean anything. You don't want to be a little bit more explicit than that. So if you recall the syntax in creating a table, and I'm going to show you on the next slide, you can actually begin to define constraints and to create table. There are two different places to define constraints in your table. It's either at the column level or at the table level. So here, take a look at this. Remember we had, we're going to create this table clients. Client number, first name, last name, yeah, piece of cake, no big deal. So note that the column level simply refers to the basically each of the columns, how they're defined. That's your column level. All right, what we're going to do here now, we're going to expand that, or we're going to recreate it. So think of that first slide. We haven't really created the table. We're not going to create the table clients, and we're going to create a primary key of that client number. And the syntax is your regular column and then data type, and then your constraint. And you use the keyword constraint. And then notice this very lengthy name of your constraint: client, which is your table name, client, which is your column name, and then number, which is your data type, and then PK is primary key. And then you tell the system that's the primary key. Yes, that is the normal naming convention for a constraint. Table, column, data type, and it's usually this is a good example of a column level constraint. And usually primary key is associated with a column, right? Makes sense? So now we created that this is the primary key, which means it has to be a unique value and the index accordingly. And I just explained all of that fun stuff. So every constraint in your database should have a name, a unique name. If you don't create a name for it, the system will create a name for it, and that's a lot harder to understand what the constraint is associated with, because it's usually something like this: sys underscore, and then some, excuse me, I think this is eight digits or 9-digit, but depending on your system. So it is important that you stick with the naming convention, and I just showed you basically the ones that are used. And remember, it is limited to 30 characters, even still now. So, so it is best to name constraints yourself because, yeah, I just stated that. So according to our naming convention, if we wanted to add other constraints to our little clients table, so that's our primary key. We want to add a constraint that not null for last name, and we want the email to be unique. So we just added 3 constraints at the column level with the naming convention for each: client number, PK, client last name, in, which is not null. Figure that out. And then client's mail, UK is not United Kingdom, that is unique. All right. Client's email. Got it? Makes sense? Pretty straightforward. All right. So all that being said, you can essentially, for this example, if we wanted to have our system level or system name constraint without actually a name to it, which you see in our database, if we wanted the last name to be not null, you can simply say not null. That is a constraint, you just don't have a name. And you should notice that whenever you're defining a constraint and giving it a name, you use the keyword constraint. And you can actually use primary key as well without the constraint name, but it's probably best practice. Well, depending on there's scenarios, but depending on what you want, in case you need to question the constraint. But here, yeah. But this is usually the naming convention. I do want to tell you that. And I just talked about that. System name constraints are absolutely accepted, and it's not a big deal. And my little squares off here. Why is that? All right. Okay. So all I'm saying, showing you so I'm showing you the two different levels in your create table. So these are all column level constraint. This constraint at the very end is what's called a table level constraint. You notice here we have constraint, a name that we're tying to the table phone and email. So we're saying that phone and email, so email can only be not null, but phone and email must be unique, which makes sense, right? And there's a reason for that. And so you have a couple that's married, and all of a sudden they have the same last name, etc. And maybe in a very similar email. And the whole idea is that you're creating a constraint that will not be violated very easily. And that's what I'm illustrating here. Violations and all right, so oh, no, I'm going to get to that. But right now, there's some things wrong with this create table that you should know of. And just to point them out, composite unique key violation here, you cannot do at the column level a composite that has to be at the table level. And a composite is more than one column. You cannot use the keyword constraint and a system level constraint. That would be, you take the keyword constraint out and it would just be not null. And then you cannot use a not null at the table level. Once again, that's a violation as well. This should be column level. That's another thing. I didn't mention that these system level constraints, and there's, well, primary key, obviously you can do either, but not null has to be associated with a column. That kind of makes sense, right? Does everyone understand that? All right.
Yep.
Good. And this is the definition there. Essentially, not null. Remember, you're associating that with a column, and basically telling the system that column cannot contain null values. And if there's a null value, you get a violation and you get all kinds of complaining. Unique, and that makes sense. Unique, usually if you want to combine, a column with one or two columns to make sure there's uniqueness there, you want to put in the unique constraint, and it's usually email or phone number. So since those are generally unique, unless there's some combinations there that could be violated. If the combination of two or more columns must be unique, for every entry, the constraint is said to be a composite unique key. Remember that, just two or more columns, that's where you use the keyword composite. And here's the example that I was alluding to. So we have Lauren Vigil, and then we decided to hire Lonnie Vigil, and they have different numbers, but their emails are basically the same. So if we attempted to add Lonnie Vigil to this database, we would get a violation because the emails are the same, even though the phone number is different, because when we set this up, we did not set up composite, meaning phone and email. So as you see, we would correct that by adding this constraint at the table level. And then once we do that, then it would be fine because the phone number and the emails are now different, a composite. And that is a representation of a composite uniqueness. So there's your example. All right, constraints created a table. When you add a not null constraint as a part of a table, and this is kind of repetitive, basically you have to remember that whenever you add data to that column, to that table, that column has to have a value for the data. That's the key for not null. And you probably figure that out. Here are key terms. Check we didn't really go over check constraint. We're going to talk about that now, I think. Constraint, column level, foreign key, primary key, not null. Remember, foreign key and primary key are usually, column level constraints, and there's other ways to form this. We're not going to get into sophisticated and composite foreign key, but primary key, but you can kind of see that coming. But usually it's pretty straightforward. There's a relationship, et cetera, et cetera. And that's indicated by a constraint across the tables. And speaking of that, we're going to get right into primary key, foreign key, and check constraints. I knew that was coming. We're going to basically, kind of know this already, but I'm going to detail the reason why we have primary and foreign key constraints, and then we're going to throw check constraints in there. We're going to demonstrate these tables within a create table scenario. We're going to evaluate a business problem with primary key, foreign key, which you probably can figure out. So constraints are used to essentially prevent invalid data entry. That's the big key. Because the way data is moving now, you can surreptitiously, that's a nice word, or just through a careless mistake, you can actually, compromise the data, and that's the key. Ensuring data integrity is the biggest thing that's part of your job in many ways. So the primary key constraint is a rule that is usually values in one column or a combination of columns, and I talked about that briefly. No primary key value can appear in more than one row, so it is the kind of the index of your records in your rows. No column that is part of the primary key can contain a null. So, and a table can have only one primary key. Remember that. And that's one thing that may trip you up, because a table can have several foreign keys. Remember that, but we'll get to that. But one primary key only. That's when you label a column primary key, that's the only primary key in that table. It's one of the first basic rules of relational database. You can have composite primary keys, which may be multiple columns. And there's a reason for that. And remember, the primary key, if you're creating a constraint, that's a primary key. You don't necessarily have to, but the naming convention should always end with the underscore PK. And here's an example that we saw before, our clients, the naming convention and how it's situated in our create table. And note that it's a column level constraint creation, which is generally what you'll see. And yes, you will also see just primary key without the keyword constraint in the name. With primary keys, you can actually, and this is where you have to use a keyword constraint and the name of the constraint, primary key, and then the column name. If you're going, you can do this at the table level. There's the difference here. This is table level. That's perfectly all right. In many instances, that probably would make sense, but normally I just put primary key at the column level and be done with it. If you have a composite primary key, which means it's more than one columns, and if you do, you will see this. Basically, you want to do that at the table level because essentially you're defining, since it's composite, it's easier to name it, and you see the long name. Copy, that's the name of the table. Copy job history ID, state, start date, job history ID and start date are your primary key. No, did I say that right? Actually, copy of the job history is your table, ID and start date are your primary key. Yeah, and it tells you here what the columns are. So that's all required if you're going to create that type of composite primary key. All right, primary keys are pretty straightforward, one per table. Foreign keys, this is what you use to create the referential integrity. And referential integrity, please subject that phrase to memory. This is that's the gist behind the relational database model. Foreign key constraints has to be designated to basically through all this, it has to be linked to a primary key on another table. That's the whole reason of creating the basis of the relationship. And I go into this a lot, but for our example, we have department ID in the departments table, employee ID, and department ID in the employees table. In this association, our parent table is the departments. Our child table, because that's where our primary key is department ID. And so just make sure you understand the relationships between the parent and the child tables in this scenario here. Because of the department ID, etc. And yes, a nice little connection there. This seems rudimentary, but this whole general association is kind of the backbone of what a relational database is. I try to illustrate this in detail where you're not null association. You have although you have several values that are associated with that, it just tells you that those individuals are in that department where you can join on. And just recall that essentially the uniqueness is in the parent table, the connection is in the child table. And I do illustrate this several ways, but just so that you understand that relationship. So when you define a foreign key constraint, it is good practice to use the suffix, basically they end it with an FK if you're going to do constraint. And remember, there has to be the relational integrity between the foreign key and the primary key. So here's in the employees table, this basically the constraint, and you used the term references because there's a referential integrity, and it's referencing the department ID in the departments table. So that's how you would define a foreign key. Notice you don't use the keyword foreign key in Oracle. In other database management systems, you do, but you just reference. Yeah, I think they removed that from the syntax. Nope, I'm incorrect. So you can use the keyword foreign key. And this does the same thing. I thought they removed the keyword foreign key. But if you're defining it at the table level, yes, foreign key, and then your column name, and then what it references, the table and column name. Okay. This is column level. This is table level. Does everyone see the difference? Hopefully I didn't confuse you too much. So you only need the foreign key if it's the table level definition of your constraint. You got out of that one. All right, so that's the foreign key, primary key association. So you do have to always maintain the referential integrity. That's the connection. If for some reason you want to enable a delete, kind of, using a cascading effect between deleting, essentially eliminating the referential integrity, you can use the key phrase on delete cascade, which means that if the foreign key does not have this particular phrase, basically you can obviously delete it. So if it has this phrase, then you can delete it from, basically you're removing the relationship. Only if it's created with this undelete cascade association. So if we look back at our parent-child relationship, if the department ID column and employees was created with undelete cascade option, the delete statement issues the department table will be X, so you can basically delete, because it's just saying, yes, we have referential integrity, but we can delete it, which is the whole idea. And so to perform this, so if you don't have undelete cascade and you try and delete or remove this referential integrity, you get an error. It says that there you're violating the referential integrity. So essentially you would add the phrase on the create table side on delete cascade. So if you wanted to delete any of the rows at this point, you can, and you'll get one row deleted because we have that statement. That's another one of those statements you have to be very sure you want to add that, because that can cause many issues if you're not careful. All right, so rather than have the rows in a child table deleted on delete cascade, there's another phrase you can use an on delete set null. I've never used this and never saw the reason, but basically instead of deleting it, it just sets the resulting impact to null, and it can be useful in case you don't want to impact the parent table. You just want to basically change that referential integrity, and that's when you would use that. And like I said, that you normally don't see that a lot, but it is possible. All right. Check constraints. Check constraints explicitly define a specific condition. And you can probably see where this is going. You can use check constraints to ensure that there's certain types of data. So here we have a check constraint that's basically referencing, making sure that our end date is greater than our start date. In our higher date, or which column is this? Our end date is, yeah, basically our end date and start date have that association. So you're checking a relationship between those particular columns. So a check constraint must only be on the row where the constraint is defined, cannot be used in queries that refer to values in other rows, cannot contain calls to a function, so you can't use check constraint with any of the system association. So the statement check sysdate is not allowed. Yeah, you can't do anything like that. It can't be used as pseudo columns, like curval, nix. We can't use it in any of those. So that statement is not allowed. A single column can have multiple check constraints that reference it. So basically, you can use it to essentially create a constraint for just about anything in your column. So, and the syntax is basically use the keyword check. So here, salary has to be greater than 0. So whenever there's any entry into that column, and you see here the syntax is, the naming convention is, the suffix is CK, and yeah. So check constraint is useful. Once again, it's a great way to validate data. Phew, there was a lot in there. Check constraint, foreign key, primary key, references, not null. And references is basically referential integrity, undelete cascade, undelete set null. All right, our final section, you're like, phew, thank goodness. So how do you manage these constraints? So we're going to list 4 different functions that alter statement can perform on constraints. We're going to write alter statement to add, drop, disable, enable constraints. Yes, you can disable or enable them, which is very useful. So name a business function requiring a DBA to drop enable. Basically, this is what a DBA will do. We'll use the cascade syntax, and we went over that a little bit. And in the data dictionary, yes, you can actually check your constraints. All right. The database system needs to be able to enforce business rules. We talked about that. A database administrator must have the ability to kind of modify rules as they come along, always focusing on that data integrity. So yes, the alter statement is used to make these changes to your constraints. So there's some guidelines. You can add, drop, enable, or disable a constraint, but you cannot modify its structure. So you can just drop it, enable it. So usually you drop it and recreate it. And I'll show you what I mean there. You can add a not null constraint to an existing column by using the modify clause in the alter table. Modify is used because not null is a column level change, and we'll see that. You can define a not null constraint only if the table is empty. That goes back to our original requirements. So the alter statement requires the name of the table, the name of the constraint, the type of the constraint, and the name of the column affected by the constraint. So you see the syntax here, alter table employees, add constraint, employee imp ID PK. So we already know that our employee ID is our primary key, but you can alter it just in case it was not. Just so you see the syntax. So that's basically adding a constraint. So then we just saw that. I gave you an example and then explain the syntax. And it's pretty excuse me, pretty straightforward for any type of constraint. So you can add a foreign key, which happens often. Alter table, your table name, add constraint, your constraint name, foreign key, et cetera, et cetera. All right. And back to our little, we already know that. And here's our alter table employees at constraint, employee department, foreign key. So we're adding the department ID, which we know it's already a foreign key if we needed to do that. And we're adding the on delete cascade too. So, all right. So there's conditions to enforce rules defined by integrity constraints. So the constraint should always be able to, in certain situations, is desirable to temporarily disable. So in some situations, you may need to disable a constraint to modify large amount of data. I've done this many, many times. So, and this usually happens in some type of batch function. Oops. So why? I just explained that. And I'll show you that. I'm supposed to show you that. All right. I think I will eventually. But anyway, to drop a constraint, you need to know the name of it. Yeah. So, yeah, I wonder why I skipped over that. I may review that, enable or disable, and add that. So don't worry, I'll get to it. Alter table, table name, drop constraint, and then name. And cascade, that means here you're using cascade, you're dropping all basically the references to the constraint if necessary. You do have to be very careful once again with this type of drop, because now you're eliminating all the constraints, which you may have to in certain scenarios. All right, so by default, whenever an integrity constraint is defined in a create or alter table statement, the constraint is automatically enabled. Okay, I skipped ahead, I'm going backwards. I'm sorry about that. By Oracle, unless it is specifically created in a disabled state using the disabled clause. So you can disable constraint without dropping it or recreating it by using the alter table option disable. Disable allows incoming data, so basically it disables the constraint. And basically use the keyword disable or enable in this way. Alter table, disable constraint, and it just disable it. Doesn't delete it, doesn't drop it. So then now the constraint is not active. And basically if you use the keyword cascade, and this is all over the place, but basically it will clear the references as well. And then hence the opposite of that, you just use the keyword enable and it will make the constraint active again. Enable and disable. That's the enable and disabling of your constraints. So if you enable a constraint, that constraint applies to all the data in a table. So basically you're reactivating the constraint. So if there's anything violated, then yes, if you added data that violates the constraint, then obviously you get those error messages and you have to go back and check all your data. If you use the term cascade, remember that's associated with the referential integrity. So you're either creating an issue there or ensuring that there's always that referential So primary key, foreign key, just be cognizant of that if you're controlling those functions in your database. And here's a good practice. If you alter a table, and you don't include the cascade constraints, any type of drop, a primary key or multi, basically it'll fail. So your cascade constraints will ensure that the parent-child, as far as the constraints are connected across the tables, and you won't run into problems if you have to do some batch job or something like that. That's the key. When cascade is not required, if a column references, so basically outside of the referential integrity, if you're not dealing with constraints on a primary key, foreign key, you can usually get away with not performing a cascade. Phew. Okay. After creating a table, you can confirm its existence by using the describe command. We know that the only constraint that you can verify using describe is the not null. So if you want to see the other constraints, you want to query the data dictionary, and it's, yes, you got it, the user constraints table. And you see this query here, select constraint name, table name, constraint type. So constraint type, and I do have a legend somewhere. Constraint type, refer RRCCC, PU. I'm supposed to know those off the top of my head. Check constraint, you probably can figure them out. Unique, primary key, you can figure them out by the name. Foreign key is R. See, I got it. C is check constraint, and you can see even that they're enabled or disabled. So these are all the constraints on the employees table. Yeah. And here's my legend. P is primary key, R is references or foreign key, C is check, including not null, and U is unique. There you go. All right. So there you go. All the DDL, all the constraints, a lot of information. I know you're all like, how do I recover from this lecture? Yeah, it's okay. You'll be all right. All right, so to briefly go over, hopefully you're all still awake. Where we are in module 11, and just to show you briefly, we got 12, 13, and 14. That's it. You get a little bit of a next week when we talk about views, and then sequences and synonyms, and then we're done. 14 is a lot, and I'm going to begin to talk about the requirements of 14 next week, but like I said, no panic. Just deal with this week because there's a lot of work to do, a little bit more than we normally have, but not too much. Some useful videos in here. The truncate table, I especially watched that one. And so you can see the difference between drop and truncate. Useful information. There's a little bit of a Oracle informational page on importing and exporting data. You should know this. I would just go through this. This is updated information. A lot of this can be useful. You don't see it much anymore, but that's what this particular section is about. And then your practice queries, DDL, creating tables, altering tables, creating constraints. All of that's in here. Please read through those, run a few of the queries, create a few of the tables. Remember, you can create all the tables you want and drop them all you want. And it's a lot of good practice. And then, what do I have here? Some constraints, some additional queries that go specifically into constraints. I would definitely read through this and run some of the queries. It's actually pretty useful. I have some tables here that you can create and add constraints. And it does give you some information about syntax and possible errors. And then your practice and solutions, and yes, there's a lot of them. Remember, we have 6 sections in this, part 1 and part 2. And there's some practice queries, more practice queries on constraints, and data and DDL. And then the last three sections of module 11. Okay. And then we have two parts, two assignments. Assignment 1, 11-1, 5 questions, not too bad. Pretty straightforward. Shouldn't be a big deal. All right. And then assignment 2, and even gives you the point totals for query 1. You only have 2, but this one is worth 6, this one is worth 2, and they're pretty straightforward. But so it seems like a lot, but it's really not that much. I only said that to scare you. But the quiz is a little longer. You have all these sections to go through in the quiz. It's a 20-pointer. And that's it. You all can handle that, right? All right. Let me stop sharing. So, once again, not too bad. A little bit more work, but it shouldn't give you a headache or anything. Hopefully you buzz right through it. If you have any problems or questions about it, you're all still doing pretty good. So keep up the good work. And we're coming to the end. Only 3 more weeks after this week. Next week, I'll begin to talk about that final week, your project, and the final. Some of the things that my expectations. The final project is not that bad. And just to give you a preview, you're just adding some tables to the schema, and you're providing an example, kind of building out like a case study. And once we get closer to that week, and remember we meet that Monday, and then classes end. Basically, that final is our finals week. So we meet Monday. You have the final to take after we meet before Friday. So let me get that out there right away. That's our finals week, including, and then the final project to complete, and some final assignments to complete as well. So it's a lot to do the final week. Sorry about that, but yeah, it's spring break, so that's why I had to kind of combine those last 2. But it's not a big deal. You'll do all right. I think you're all learning a lot. I can see the performances going up. So once again, keep up the good work, and we'll get through this together, right? All right. So that's all I have for this evening. A little bit longer, but we survived. I don't think anyone's asleep. At least no one with their camera on is asleep. Although I can't see Evan. Oh, there he is. I can see the top of his head.
I will be soon.
Yes, Daniel, I understand. All right, thank you all. I appreciate your attention. I will see you all next week.
Good night.
Good night.
Guys. Thank you.
Thank you.